Hey guys, I just wanted to give a quick heads up before I jumped into the challenge. This wasn't the smoothest of my walkthroughs. I came along some bumps in the road with the initial access. I eventually did fix them and gain the user flag, but it took a bit longer than I would usually take to solve them. And also for the privilege escalation part, which was a buffer overflow. I'm not an expert on buffer overflows. It wasn't smooth at all, and my explanation wasn't perfect. I'll include some resources and some links in the description which probably offer a better explanation. Enjoy. Hey guys, it's Ben, and today I'm going to be walking through the Frolic HackTheBox challenge. This is an easy rated Linux box, which to be honest I didn't find too fun. The user flag was quite CTF-esque. It wasn't really applicable to any real life situation. And the root flag involves some binary exploitation, which I'm not that good at, but I learnt some new stuff, so yeah, let's get on with it. I've got the box up and running, as you can see. Like always, I'll start with an nmap scan. I'm going to scan all ports with TACP, TAC-SV for a version service version enumeration, scan TAC-SC for NSE scripts, that's the nmap scripting engine scripts. That would just give us some more information onto the services which are running. TAC-T4 for a speedy output, TAC-N to not do a reverse DNS resolution check, TAC-PN to not do a ping check. These last two just speed it up a little bit. These last three actually make the scan run a bit faster, and I'm going to output that to full_thorough.log. I have already done this, so let's just have a look at the output. We'll cat out full thorough, and we can see the flags there from the command I run, and we can also see the ports which are open. So we can see port 22 is open, running SSH. We see the software is open SSH, and then we can see we've got two SMB ports here, 139 and 445. This, for some reason, it looks like it got corrupted and wasn't able to figure out the software or the protocol. We can see it's a Samba server, which is like Linux's implementation of SMB, but it can't, for some reason, figure out the protocol here. But that would be SMB, or it may be NetBIOS SMB, something like that. We see we've then got a HTTP port, not open on the default 80, but open on 1880, and we can see some sort of Node.js Express server is running that. We can see there's the title Node-RED, so we can keep that in mind. And we can see some more output from the NSE scripts. We've got a hash from the favicon, the little icon of that website. This is what the favicon is up here, but yeah. We've also got another HTTP server running on port 999. This looks like and just like the default splash page for Nginx. We can see welcome to Nginx, and then we've got some more information from the NSE scripts about the SMB, account use guest, authentication level as user. We can see some more information down here, computer name Frolic. So yeah, we've got enough information to start doing some further reconnaissance. So I'm going to make directory for SMB and then just see if there are any shares available. I'm just going to use SMB map and then TAC-H for Frolic.HackTheBox. And one thing I forgot to mention, if I go over here and I'll zoom in, sudo vi etc hosts, we can see down here 10.10.10.111. I've added the host name to my etc host file so I can reference Frolic.HackTheBox instead of referencing the IP. So just for example, Frolic.HackTheBox, I can ping it and we end up pinging the IP of the box. So that's all set up. We can see we've done the SMB map. It doesn't look like we have any permission to access either the print share or the IPC share, which isn't the end of the world. Maybe we'll come to that later. We will see. There were obviously two web servers, so I'm just going to make directory web, and then I'm going to make 1, which is going to be the first one, 11880. I'll make that directory there, and we can check this one out. So we can go to http frolic.hackthebox, and then that's on 1180. We can see there's this node red here. If you want to, you can have a look at the Wappalizer to see the web technologies in use. You may actually search for node red just like this, and then we can see, look, it's not a custom built web server. There is actually something you can download, and it's a flow-based low-code development tool for visual programming developed originally by IBM. So when I originally saw this, I was thinking, can I get some sort of version disclosure, and then see if there's any inherent vulnerabilities, any CVEs for this Node-RED. I wasn't able to recover a version for this, but we can do some fuzzing and just see what we can find anyway. So let's do that. I'm going to use fuff tacu http frolic.hackthebox. I'm going to do port 180. I'm going to filter code 404. So if we go to a non-existent file like this, we see we cannot get this, and we get a response of 404. So I'm going to filter code 404, and then the word list I'm going to use. So this basically works by having a word list of possible directories or files and going one by one, trying it, and then if we get a 404 error, discarding it. It will, where we've got this fuzz in capital letters here, it will replace the word from the word list. So we can use user share word list, sec list, discovery, web content, raft. I'll start off with directories, .txt, and then we'll tee this to dirs.log, and I'm going to zoom out of that, and we'll see what we can find here. We are seeing we're getting some 401s, which aren't any good either, so we can also add that to our filter. We can go filter from 401 as well, and we can see there's this red directory. It gives us a 301, so that's going to redirect us to somewhere. There's also a vendor directory, so let's just have a look. Red, and it redirects us to here, and it says cannot get it. And do we get a 404 there as well? So yeah, for some reason we get a 404 there. If we send it just to red like this, we see, and that's not what I want to do. Go like this and put HTTP there. I do want to clear this, just so it's a bit easier. So we see we get the 301, that redirects us to the 404. So perhaps there'll be further directories after this. There may be a directory down here, and that's why it redirects us and doesn't give us the 404 straight away. We also got that for vendor as well. I'm not going to dig too deep into this, but I will have a look, see if there's any files of interest, and then we'll go raft medium files.txt as well, and I'll do the same thing here. We can see there's a favicon.ico, which is just like I said earlier, this little image up here in the corner, and that's not of any interest to us. So I couldn't really get anywhere with this. You may want to just look up exploits, GitHub. Perhaps there's some remote code execution here. There is some vulnerability, or there is some possible attack vectors through Node-RED, but I didn't want to spend too much time on it as I couldn't see any quick wins straight away. So I decided to have a look at the other endpoint we've got. So if you remember, there was also a web server, Nginx on port 999, and we can see we get that splash page saying welcome to Nginx. For some reason this confused me. It says thank you for using Nginx, and then HTTP Frolic, and this is Frolic, the challenge. So I don't know what happened here, why the host name is Frolic. We can see like the actual host name is Frolic, and it's not. So yeah, I was confused about that, but yeah, it's not the end of the world. Like I did some fuzzing with this one, I will do the same for this Nginx server, and see what we find. So I'm going to make directory 999. We can cd into there, and I can do some fuzzing again. What I'm going to do is I'm going to use these same same commands. I'm just going to change it around, so I'm going to replace the port to 909, and that looks about right. And we are finding stuff here. A lot of them are 403s. That's permission denied. We won't be able to access that. If we look, there is basically nothing. There's no files on this top level directory. What about directories instead? Can we find any? I don't want to keep the fuzz there. I just want to change the word list. So I'm now going to fuzz for directories and see if we can find any top level directories. Dirs.log. And we can find some directories. We can find 4 directories, 5 directories now. So we've got loop, dev, backup, test, and admin. What I am going to do is I'm going to use recursion, so we can, after it finds the top level directory, for example, after it finds the admin directory, it will then fuzz from admin onwards, and the same for every other directory. This will just give us a better coverage. So I believe the flags like this, recursion, tag recursion, like that. And you can see it's now adding a job, admin, fuzz, and then it's fuzzing from test, backup. So we'll be able to find more stuff. So let's start at the top. We've got this admin directory. Let's just have a look. Go to admin, and we've got the title crack me, and it says come on, I'm hackable. We've got a username and password, and note nothing. We could just try as a test default credentials. We log in, what happens? You have left to attempt. So it's a bit of broken English there, but let's have a look at the source code. We see it's just like a HTTP form. We've got a username and a password, and then when we click the submit button here, or the login button, on click, when we click it, it uses this JS function validate. Obviously that's not defined in this code here, however there is an external JavaScript source code reference, this login.js, so we can assume that the validate function is in here. We can go here, and shockingly the password and the authentication is dealt with client side, which is worst practice ever, as anyone can basically see how authentication works, and in this case we can just recover this password here. So I'm going to create up the top just creds, because we can create a place where we can store all the credentials we have captured. So I'm just going to go suball creds.txt. I'll put that one there, and it's actually admin there. So we've got one set of credentials here. We can see when you do log in with this, it redirects us to success.html. So can we just access this without any authentication? Success.html, and I hate when it does that. Success.html, and it was obviously under admin, so I was in the wrong endpoint altogether. There we go, and we've got some weird text here, right? Lots of question marks and exclamation marks and full stops. It doesn't really say what's going on here. Is there anything commented here? There's not. So at first I thought this may be encoded with something, and I wasn't really too sure what it would be encoded with. But let's have a look. There's a good website, I can't remember it off the top of my head, but encoder, detector, I think it's like decoder, something like that. Yes, decrypt a message. So it will identify the encoding which is used, and then we'll be able to decode it if there is, if it is encoded with like a common method. So we can analyze this, and then it will give us the results of what it thinks it's been encoded with. So substitution cipher, or OK. This has a higher, a much bigger chance of it being this OK encoding, which I hadn't ever heard of. But we can put this in here, and we can execute this, and let's just say consent. It decodes to nothing to check here. So I'm going to do another text file, say decode, and I'm just going to sort of copy what we've got so far here. So we'll paste that there, and that's not what I wanted to copy. Let me just go out of here, copy that. That's the first stage, that decodes to this here. And it's been quite slow at the moment, that's fine. That decodes to this, and then obviously it says nothing to check here. We ought to check this endpoint, see what's going on. So we'll go back to here, and then we can just change this here and see what is hidden on this endpoint. And it looks like we've got some base64 encoded file or data, so we can copy this here, and then I'm going to open CyberChef. And CyberChef is such a great tool. I love it. I don't think it has OK encoding on it. We can just check this, like OK. No. But we can place the string there, and then we can decode it with base64 from base64. And we can see we've got some raw data here. We have a PK at the beginning, which you may have recognized. This is like the magic byte for a zip file. And then we can see, if you actually look inside, we've got this index.php. So what we can do, just to verify this is a zip file, we can say file type or something, detect file type, and it will tell us this is a PK zip archive. So what we can do is we can export, get rid of that one. We can export this, save output to a file, download.zip, and then I'm going to go over here, I'm going to move download.zip to this directory here, and now we've got this zip file. So we've got the zip file there. If I try unzip this, download.zip, we see it asks us for a password. We don't know a password, so we don't know what to do. We can brute force the password, or we can turn this encrypted zip archive into a hash and then crack the hash. The second method is a lot more faster than brute forcing and trying all these different passwords. So let's just really quickly do that. We can use a tool called zip2john, and this will convert the zip file we have into a hash. So I'm going to call that zip hash, and then we've got the hash there. And then what I can use John, you could use hashcat or whatever, zip hash, and I'm going to supply the word list, user share word lists, rocq. I just want to show you, if I cat zip hash, it's got download.zip, index.php is the file inside, and then we've got the actual hash here, pkzip, and then the actual hash data. So we can use this and go over here, and we can crack it. It says no password hash is left to crack because I've already cracked it. However, if you were doing this, it wouldn't show you that. So I can use show, and this will show me the hash. And the password is there, and the password is literally password. So you could have probably taken a lucky guess and unzipped download with just the password, and that decrypts it. That unzips it and decrypts it, and we've got the index.php. So we can just have a look what this is, index.php, and it looks like we've got a load of hex. So I'm just going to go. So we eventually get a zip file, which when we unzip, we get this. And we've got this, what looks to be hex, so we can once again take this back to CyberChef, and it looks like I didn't have it selected. Let's go back over here. We'll copy this, Control C, there we go. Copy this. We don't want to base64 decode it, we do want to hex decode it. Hex from hex, drag and drop that there, and it looks like once again we've got base64 decoded data. So, and this is, when I said at the beginning this user flag was very much CTF like, this is exactly what I was on about. It's not enjoyable at all. It's just like loads of different encodings stacked on top of one of each other. You'd never see this in real life. So yeah, but we can see this is base64 encoded, so we can chain together two operations and base64 decode this, and we've now got this, which I do recognise this encoding, and I recognise it as a brainfuck encoding. So excuse my French, I don't think CyberChef has it, but if we go brainfuck decoder, and if you didn't really recognise this, you may want to use that tool I showed you earlier to identify it, and we can paste that in there, and we can say interpret this or decode this, and we get an I don't know what is pass. So after all those steps, all those encoding and zip files, after we get to the end, we get this plain text string, I don't know what is pass. So this could be a password. So we can copy this, and I'm just going to put this in creds. We don't know what the username is, but we have a possible password here. I don't know what is pass. And that's the end of that first admin directory we went to. There are further directories like add test, backup. So let's just go have a look around those, right? Let's start on test, and where does test take us? And we'll go to this top level directory test, and once again it Googles it instead of going to the website test. Now I can put HTTP in front, and we get the PHP configuration. So there may be some juicy information in here. You can look around and see if it reveals anything about, look, there's a MySQL server running in the back end. It could reveal a lot of information. You would never want this on a production website to have the configuration accessible to anyone to see. That is a no-no. Test gives us that. There was this backup directory, and there's also a dev, so we'll check out the backup directory. Backup, and once again put the HTTP in front. We can see it looks like this is displaying a possible like files which are on the next level directory. So there could be a user.txt, and we'll have a look, HTTP, and there is, we've got this username of admin, and then we can expect there's also a password.txt. So we've got another set of credentials. If we look at the password, at first I thought this may be the user flag, but it wasn't. And then we've got a password, I'm not human. There was also a loop directory, so we can check that out as well. Loop, go to here, and we get a 403 forbidden, so that's not accessible. If we go back to our directory enumeration, there was this dev directory. Let's have a look at the dev directory, and I can get rid of that. Sorry about this. HTTP dev, and we get a 403 forbidden there. What else is there? Dev. It looks like there's a dev backup as well, so let's just have a look on here. Dev backup. There's a further directory from this, and we see this play SMS endpoint, which we haven't seen before. So play SMS, let's check this out. We'll go to play SMS, and for God's sake, HTTP play SMS, and it looks like we've got a login portal. You may want to search play SMS, and we can quickly verify this is like a legitimate platform. You can download the source code on GitHub. It's not a custom built website for this challenge, but we do have a set of credentials. So we can just try from the bottom right, admin, I'm not human. I'm not human. We'll see if any of these work. And what you may want to do, you may also want to try them on here as well. So admin and then I'm not human. Just see if we can log into anywhere. We've got a set of credentials. You just want to throw them everywhere and see what we can do. We don't know what the username for this is, but we can take a guess. It's admin. You may want to automate this with Hydra, but as we've only got a small amount, I can do it manually. We'll just throw this here and see if we can log in anywhere. Can't log into Node-RED with those set of credentials. What about here? And we can log in with admin. I don't know what is passed to the play SMS. There's one set of credentials I haven't tried for this Node-RED, and I will try them here. Well, I've got the username admin, don't I? So I can do the super duper password underscore lol. And we'll put this here, enter, and we get a login failed again. We can't log in with any of the credentials we've recovered to the Node-RED web server on port 1880. We have, however, logged into Play SMS. So you may want to look around to see if there's any ways to get remote code execution. You may want to look around settings features, or you may want to do some Googling for RCEs, but we can just have a look, see manage plugin, what does this do? It looks like there's all these plugins. You may see, is there a way I can add a plugin? It's sort of just having a look, main configuration, having a look and playing around until you find something, and if you don't find like a manual way to exploit it, you may want to Google for possible ways to RCE. So, and that is exactly what I'm going to do. I'm going to go play SMS RCE. One thing you should also be looking for, and I couldn't actually find, I couldn't find a version disclosure on, even once I'd logged in as admin, I couldn't find anywhere which disclosed the version, which would be helpful, because then I know if X version of Play SMS is vulnerable, I can Google for that, but I couldn't find any of that for some reason, but that's fine. We do, when we search this, we do see a CVE here, but like I said, we don't know the version we're running on. We could try this. That is not actually the one I looked at. What about this exploit DB one? Can we find one on here? If we have a look, it tells us some more stuff here. Gives us instructions. So this isn't actually, I don't think this is a proof of concept, but it does give us instructions on what to do, or what we could do. I'm looking for a particular one which I used, which wasn't the best, I'm being completely honest, but it does look like there are other versions here. This is the proof of concept I did use, and it's for version 1.4.3, so it could be earlier than that, but I don't know the version. Maybe I couldn't find it, but it says you log into, you go to this endpoint here, and I will do that. I didn't want to go to there at all. Let's just go back one, and I will go to this endpoint here, and that is not where I wanted to go either. Let me go back to this proof of concept. It was it this here? Let's try this. I'll know it when I see it. Those are identical. I don't know why I can't find it now. Let's just go from here. I'm sure it's identical than this. If not, I've got it on another screen which I can have a look at. Let's find it then. Cool main config. I think it's because I was on the wrong one of these. It's the information page I was looking for. This one here. And basically this is like a splash page for the main index.php. So if I just duplicate this and then just go to the index.php, we can control the splash page. And I'll show you what I mean. I can say, please subscribe. We can save this and submit it. And it says we do not have access. For some reason, half the time it lets me do it. So I'm just going to go please sub. Again, I'll do it again, I'll copy this. When I save this, it works once, and then the next time I do it, it doesn't work. When I go here, we've now got please sub here. So what we can actually do is we can include PHP code in here, and we can just get command execution as simply as that. So you may want to do like system ID, like so. I'm going to copy this. I'll save this, and it'll probably give that error. I'll go back once, and I'll do it again. I found it really fiddly, having to do it twice, or every other time you try upload a payload, it doesn't work. But we can now see you've got the successful output of the ID command there. We can see the web server is running under the www data user. So you may want to put a rev shell in here. If we go to revshells.com, I think that was it. Yes, it was. We've got my IP in there. What you may want to do is copy this and get a listener going, and I will do exactly that. And I'm going to get rid of this, exit netcat nvlp 444, and then we can just try a load of different payloads, see if we can get a reverse shell by doing this. When I originally tried, didn't, and I wasn't successful at doing this, getting it this method, but I'm going to try again just to see if I was missing something. And we go like that, we'll close it, and I'm going to copy this so I save it. If I get a permission denied, I can just paste it in again, save it. I don't have access, go like this, put it in again. It's updated this time, but look, it's got rid of the PHP tags at the beginning, and there was nothing wrong with it. I've got it pasted there. That is completely, it's valid PHP, so I don't know why it's done that. If we go here, it will literally just show us we don't get a reverse shell. It doesn't work. So that was a bit annoying. You may want to try a different payload. If we go here, see if a different payload makes the difference. I'm not sure if, because the text gets messed up when I do that, if it's something about the font or the size or why it's not working. You may want to change the double quotes as well and see if that makes a difference. Have I got two there? I've got one. I'll control copy, so I save that. We get that permission denied error, but we can just do it again without an issue. Save. It saved it, and once again it's cut it off, so when I refresh it doesn't work like that. It looks like it's sort of broken there, that whole entire screen. I'm just going to go back to this, overwrite it, and see if this fixes it. And then I'll show you what I actually did and what does work. So if I go here now, we're back to the normal page. That is all good. Because I couldn't get it to work like that, for some reason, I couldn't get the reverse shell to work when it runs from the website. What I did is I copied one of my reverse shells. So I'm just going to go back up to the top here, cd into the exploits directory, and then I'm going to copy one of these reverse shells. So let's just use the usual bash one like this. This shouldn't be an issue. And I'm going to say s.sh for shell.sh, put that in there. And now I'm going to host this on a HTTP server, python-tacm HTTP server. And now, my command execution, I'm going to go PHP system, and I'm going to wget this from my IP address. So 16.16.3. You cannot see that as it's hidden by my face, but you can see up there my IP address is 16.10. I said that completely wrong. 10.10.16.3. And we can download this s.sh and go like so. I'm going to copy this, so if it doesn't work, I save the payload. It doesn't work, I can put it there again. That worked. That saved. When I refresh this, I don't get anything coming through because something is broken. What did I actually type in here? let me use double quotes, see if that makes a difference. I don't think it will, because I don't know what's broken on this. And then that's probably not going to work altogether, so I'll get permission denied, yes. Put this here again, that works. If I refresh this, don't get anything. If I just go to index.php, for some reason, if I save this now, try again, get rid of this, for some reason it's not working like it was before, but I'm sure we can figure it out. Get that main page back, that is good. So we can put the PHP we want to execute there, PHP system wget, put my IP there, close it, use the semicolon. That looks good to me. I get that permission denied error again. Save, configuration saved, and I reckon it's going to go blank. That is so bizarre. I've got no idea why I'm getting that. Before that did work with me, and I'm just going to check, because I've got my write-up on this side. If I use something else, no, it was literally identical. Literally identical. Maybe I broke something when I was trying and playing around with the reverse shell. I'm going to try one of these other payloads, because it's worth giving it a go. If my original method of manual exploitation didn't work, maybe one of these will. So I think this play SMS, this version is quite vulnerable. So we may be able to try an alternative method. But if you're doing this at home, give that method a go. With the identical command, wget it, download it, and then you want to use chmod to make it executable. And then how I actually got execution was, I'll show you, I'll just write it here. Once I downloaded it, what I did was went like this. I catted s.sh and piped it into bin bash, and went like this. Once it was downloaded onto the box, and that worked fine, and I got the reverse shell. For some reason, it's playing up today, which is totally fine. Did I definitely? Yeah, I've lost it. It's fine. I'll try this other proof of concept. 2017 subl play SMS shell. Let's have a look at this. So you can see it uses argpath, so it's probably taking in the command line arguments, the username and password, and all the other details. Yeah, there we go. Interactive C. So yeah, let's just give this a go. Right, we probably want to change this to admin, seeing as we had, it's a bit different. Play SMS shell. So obviously the username in this case is admin. The password is what was the password in our creds is I don't know what is passed, so we'll pass that there. The URL is frolic.hackthebox and port 999. I do want interactive mode, and we'll see if this gives us a shell. Max retries exceeded with URL. It couldn't establish a new connection, and that is because I got the hostname wrong. Could not receive the login page. Where does it go for the login page then? Where do we get that error? Could not. Oh, it doesn't spell couldn't, right, that's why I couldn't search it. Let's find it manually then. So if status code is this, try session get.login URL, that's admin.index.php. Let's just check this is right, and if not, we can probably play around with it. Oh, it's play SMS. It's play SMS, not admin. That is probably why. If I try this again, and I've got that wrong, logged in, grabbing CSRF token from phone book import, could not determine the CSRF token. I'm going to give up with that proof of concept. I'm going to see if there's any other GitHub POG. See if we can get a different proof of concept. Instead, it looks like there's a pre-auth one. What is this one here? What does it do? How does it work? So it logs on. It does something with CSRF token as well. I do want to give this original one a go. I just want to see if I just get. I don't know why it didn't work, but it worked earlier. I'm sorry for this. If I just go this, save that. Oh, fuck's sake. BHP system ID. Can I just get command execution like this again? Does this work? That's saved. And then if I refresh here, I can get that. It's just for some reason when I do wget, system wget on HTTP 10.10.16 free s.sh, whenever I do this, I get that issue. Let's try again, see if it's fixed itself. Go back, paste it in there again, and then go back here. That looked better. That looked a lot better. Let's just python tacket HTTP server, refresh this. We've got the request, so it's working now. For some reason, I'm pretty sure it was identical earlier. I don't know why it wasn't working. So let's quickly apologise for wasting your time with that second proof of concept. Maybe it just needed a second to reset itself. What I can do is cat s.sh and pipe that into bin bash. I'm going to copy this, paste that in again. That runs, and then I do this, and it hangs, which is good. It doesn't load. That means we've caught the shell, and we're able to move on to the second part with, we've got the user flag in a second. I always like to check what version of Python is installed. We can see it's just the usual Python instead of Python 3, and then from that I can get a tty shell with import pty, pty.spawn, bin bash, export term equals xterm, and we can go to the home directory. We can have a look. There's two users. Obviously I'm not either of those user. We can cd to IOSH, and we can see the user flag is there, but it looks like for all others there is read and execute over it, so we are able to cat this out and get the user flag. There we go. You may have noticed there was this .binary in their user profile, which obviously it's not something you would usually see at all. So we can just have a look, .binary, what's in here. And there is a SUID binary in this user AOSH's home folder called ROP. And it's owned by root, and it's in the group of root. And yeah, that interested me because I've never seen this before. So can I execute this? And it tells us we have to supply a command line argument like please sub, and it says message sent, please sub. When I see something like this, what you may want to do is just want to run strings on it just to see what is going on. Strings on .rop, and we can see there are some puts. There is string copy, there's printf, you can see the functions. There's something called a vuln, so maybe there's a vulnerability in it. At this point, I was almost certain this is how we were going to privilege escalate. It looks like, by looking at the functions, especially string copy, there may be a buffer overflow vulnerability, and this is how we were going to privilege escalate. The reason I say it's obvious is because it's also SUID. That means whenever I run it, I'm running it with the permissions of root. So if I run it, exploit it, and get it to pop a shell, which you can do through some buffer overflow attacks, I will be able to get a shell as root. So this is where it gets tricky. I see we're already 44 minutes in. I did struggle on that user part for some reason for a little while, so I've already got this binary on my machine. You can move it across. I'm just going to copy this because how you would move it across is Python simple HTTP server, and get or you do TACM in front of that, Python TACM. You could also do it with netcat, but I don't want to kill my shell, and this will kill my shell. You'd press enter, and then that would get HTTP server going. You could then wget it and download it like this. I'm not going to do that because I don't want to kill the shell, and I figured once you kill the shell, you can't recover it. Once you've started this reverse shell, you have to reset the challenge if you want to do it again. So I'm not going to make that mistake. I am just going to copy from desktop HackTheBox Frolic, and then we know it's called PE and ROP, and I'll move it here. So I'm going to make a directory PE for privilege escalation. I'm going to move ROP into PE, and I'm going to cd into PE. What I'll do just to verify this is the same file, MD5 summit here and MD5 summit here. We can see they get the same hash. So this is the same binary. If we execute it, we've got that usage program message. So if this is a buffer overflow challenge, as a good test, you can always just spam a load of A's in or whatever characters and see if you get a segmentation fault. And that's exactly what I'm going to do. That should be enough. And we see, look, we get a seg fault. So something's happening there. It's overflowing in memory and it's corrupting it. It's getting a seg fault. What I like to do, as I'm not an expert on this, is just open this up in Ghidra and then see what the raw C code is saying. And this will just give me an understanding of what I'm doing or where I should go from. I have got it. Ghidra again. Sorry. There we go. Analyze. Yes. Yes. Analyze. This will give us the source code. Yes. So we'll start at the main function like we always do. Main, undefined main. We can see the main takes two parameters, parameter 1 and parameter 2. Parameter 2, if it's less than 2, it will display this message. So if we don't supply a command line argument, it will set uvar 1 equal to this f's, and it will display that, and that will just kill it. We look, it just returns after that. And then in all other cases, so when we do supply a command line argument, we see this vuln function is called, and it's passing parameter 2, something about the memory address of parameter 2 plus 4 as an argument to that. I barely know any C, but I can just about read it if it's sort of like pseudocode, so I may be butchering this massively. But we can go to this vuln function, and we can see we first define local 34, which it won't be defined like this, but this is how, when we decompile it, it comes to this, and we choose the buffer size for 48, and we see this is used here. So string copy, it takes in the size of the message we're sending and the actual message. So in this case, as we're doing larger than 48 bytes, it will overflow it. I believe it's something along those lines. So string copy is the vulnerable function here. That's where the issue is, and then it prints it. If it isn't overflowing, it will print it like normally. But at this point here, it is, yeah, this is where the issue occurs. So obviously this is ROP. You can do some Googling. You may find something called return-orientated programming. I, in this case, used a return to libc attack. This is how I did it. I'm going to quickly find an explanation online because I'm going to butcher it massively. return to libc. Basically, there was a good one. Let's see if I can find it. Maybe it's over here somewhere. Yeah, Ironstone. He has a very nice write-up on return to libc. Basically, when we overflow it, we want to write into the instruction pointer. This is the EIP register, and we want to change that. So we can change the EIP register when we overflow it, such that we can control the where the function goes to, where the we can control where the next function takes us, and we can basically send it to do our own thing. With return to libc, what we can do is we can overwrite the instruction pointer and then redirect it to the system function found in the libc module. So if we go back to our code here, we can use LLD or LDD on ROP, and we can see libc.so.6, and we've got this memory address for it here. In this file, there will be a system function, and this is literally a bit like the PHP system function. It lets you run system commands. If you go man system, you can see it here. It executes a shell command. So we want to, when we overwrite it and we fill up with our junk, and we want to overwrite it, we want to go to this system function, and we then want to return, and then what we want to do is we want to pop a shell. So we also want to include the string bin sh. I'm massively butchering this, but I think maybe if I get some code out and sort of explain it, it will make a bit more sense. What I do want to do is get GDB open with command line args. Can't remember this off the top of my head. What we can do, we want to find the original amount of bytes we have to do to overwrite the EIP. So let's just say buffer overflow EIP calculator. What this will do is this will give us a string like this, and it will allow us to find the offset by looking at the EIP register, which is basically the amount of padding we have to do before we include our malicious payload. So let's just go GDB, and I also want to look at the syntax. Command line arguments with GDB. Yeah, it's like this. So GDB args ROP, and then I will include the payload there, which is identical. We'll run this, and we go up and we can find the EIP, which is the next instruction pointer. Overwrite is this. So we've overwritten it with B7AB. If you look in the original string we supplied, there will be a B7AB, which is here. And this will tell us how many characters are required to overwrite it. We'll put the register in there, which is not, I didn't want to copy that. I want to copy this, and this will tell us the padding we need to supply, and that's 52 in this case. So I'm going to start writing, I'm just going to exit this. I'm going to start writing a poc.py, and I'm going to use the pwn module from pwn tools. The binary, the file I'm going to use is ROP. The padding we know is going to be 52 times A, because any more than this it will start overwriting the instruction pointer, and that's what we want to do. Before this, it's fine, it won't override the instruction pointer, and then anything we add after the 52 A's will overwrite the instruction pointer, and then we can choose, basically control where to go in the execution flow. So from that point we can choose to go to the system function after this. So what I'm going to do is I'm going to use, we'll go over here, I'm going to use the LDD. Actually, I'll do it in my HackTheBox first, and then I'll adjust it for the one on here, so we can test it here first. I'm going to go down, go into the PE directory here. We can use, like I did earlier, LDD the ROP. So we know we've got this libc module here, which contains the system function, and it also contains, if we go back to here, it contains the system function found in the C library. This function is anything you pass to it, making it the best target. There is also another string bin.sh found in the libc library, and we can pass that string to the system function to pop a shell. So we have to, first of all, we want to find the libc. Where is this libc base memory address? And we've got this here. This is the base memory address here. So we can include that in our Python code. And then I want to find, in this libc file here, where is the system function located? So what I can do is I can do strings, tac A, tac T, tac S, and let me just go, I want to find system. So this will find the system function, the memory address from the base of the system function counting down, and I've done something wrong there. Readelf is what I used here, sorry, totally wrong command. Readelf will allow us to find the system function in comparison from starting at the top going down. So if you start at the top and go down in hex, at this location here, there is the system function which we can call. So I'm going to say the next variable I'm going to define here is system offset from libc, and we'll equal this to pwn.p32, and well, the system offset is here like so, and there we go. We can get rid of all the leading zeros, and we've got the system offset from libc. So if you start at this libc base address, which we found through doing the LDD command, this F7C000, we go down this amount in hex, you'll then get the system function. What we also want to do is we want to find the return function, which is just exit. So I'm going to go readelf grep exit, and just this exit one here is this. So I'm going to say exit offset from libc, and that is equal to this. There we go. And we also want to find the string bin.sh, so we can pass it in as the command line arguments. We can pass it in as the parameter to the system function, basically running system brackets bin.sh in the middle. So we can grep for bin.sh like so. And I don't want to readelf at all, I want to strings it, and I had it up there, bin.sh, and we can find that location here. So bin.sh offset from libc, and we'll set that equal to there. So that is the offset when compared to the base of the libc base, so the beginning of it. The payload, what we want to do is start with that padding at the beginning. So we'll start with the padding at the beginning. We then want to get the memory address of system, which is just going to be libc, which is just going to be the libc base plus the system offset, system underscore offset from libc. So that will give us the system function. We then want to return the system function, and we'll and that will be with exit. And there's something I'm doing totally wrong here. These should be bytes here, and to get it into format such that it will accept it, we'll put this in pwn.p32, and I'll do this here as well, pwn.p32. We want to do the same thing here. We want to find the libc base, and then we'll go forward by exit offset from libc, and then finally I want to add on pwn p32 libc base plus bin sh offset from libc. I'm just going to sub all this. It's probably better to read it in here. We've got the padding at the beginning, then we've got the system function. So we're going from the base address of libc module. We're finding the system function by going forward this amount, by going forward the offset, and then we're doing the same for the return function. We're finding the base, and then we're going forward by the offset, and then finally the parameter which is being passed into the system function is bin sh. We're starting the libc, and then we're looking for the string of bin sh, and we're going forward that amount. We can print this payload here, and let's just do that, and we'll see if this works. Python poc.py. We've got that there, that works. So now what we can do, if we go rop, and then I'll just go Python poc.py, we get a segmentation fault. Something isn't working here. I know you can do it this way instead, so can I do it this way? You can actually run the process in interactive mode here. So pwn.process, and then we'll supply the binary here, and then the payload, p.clean and p.interactive. So this time we're running, instead of supplying the number of bytes in the command line argument of Python, we're just going to run the Python script, and it should execute the binary like this. This does work, so it's something about supplying it like that which doesn't, which is a bit strange, because that's what I did up here. But let's adjust this, and we'll just give it a go up here and see if we can get it to work. If you look, for example, if we go LDD for ROP, the values are different, so I'm going to have to basically adjust it for this. In this case, the libc base is going to be this, and then I can read elf tac s, and then I'll copy I just copy this here. It's probably easier. Copy, delete. There we go. I don't know what I'm doing wrong here. Is that right? Read elf s lib i386 linux gnu libc.so.6. That's fine. So let me just get that again. Oh yeah, it's because I'm doing the wrong thing here. I'm grepping for system, and we'll find the system function here. I apologise for being my explanation of this being very poor. Like I said, I'm learning this for the first time, so it's sort of I don't understand it 100% myself, but I can sort of get it to work. Grep exit, because we want to get the return function, and then we'll do strings for the last one, won't we? oxd, and then we'll go strings a t x lib i386 linux gnu libc.so.6, and we'll grep for bin sh. We can find that string is 15b AOB. There we go. We can find the offset for that. Nice. Obviously, if we run this on our computer, this will not, sorry, if we run this on the Kali host, this will not work because all the numbers are different. But I can print the payload out just to get it like this. P is not defined. Obviously, those can get commented out. And I'm going to move this up like so. Clear this, print it. We've got that there. What I'm going to do is I'm just going to create another vi temp.py, and I'm just going to go print, and then I'll print this here. I'll get rid of that. There we go. So if I python temp.py now, it prints that out. I can get a HTTP server going here, get rid of that one. I can now go to my temp directory here and wget http 10.10.16 free temp.py. There we go. If we python temp.py here, we can see it outputs the bytes and everything there as expected. What we can now do is try go home aush.binary rop, and then you've obviously got that there. This time, what I'm going to supply as the command line arguments is python temp.py. If this doesn't work, I'm sort of stuck, and I've done that wrong. That should be rop, and then we'll supply python temp.py. And it looks like we've got a shell. We go ID. We're running as root. We successfully privilege escalated by using a return to libc attack. I'm going to quickly go over what we did again, and just so I can show you, we can now cd into the root directory. We can cat out the root flag. There we go. Nice. So we had the padding, so we could overwrite the next instruction pointer. And then we looked at the memory address of the libc base, and then we looked at the offset to the system function from the libc base, which is this value here. We also looked at the offset to the exit function, and then we also looked at the offset to the string bin sh, which is contained in libc. And we use those offsets to first of all call the system function, and then give it a return, and then the actual the argument we pass into the system function is bin sh, and that pops a shell. I really hope you sort of understood that, but if you didn't, it's fine. Blame it on my poor explanation and my poor understanding of binary exploitation. But we got it to work. That's all that matters. I hope you enjoyed this challenge, and I'll see you on the next one. Cheers.